Welcome to the Pythagorean Theorem Facial Recognition app. We have 40 different people here with 40 different faces that the app stores, and the app actually stores 10 different poses for each one of these people. So for example, if I click on this face here, I'll get 10 poses that belong to that particular person. Now if I click on one of these faces, well, we have a total of 400 faces. 40 times 10, 400 faces. And the app will go and look at all 400 of those faces and find the 10 that are closest to that face based on its algorithm. So I'm going to click on this face. Okay, so here's the 10 that are closest to that face. Now some of these things have a frame of green and some have a frame of red. The ones that are framed in red are mismatches. The ones that are framed in green are good matches. Now if I click on one of these faces, any one of these, well, first of all, the ordering is, this is the closest, second closest, third, fourth, fifth, and so forth, sixth up through 10. Okay, now if I click on one of these faces, what it will pull up is the compare screen. And the compare screen gives us a low resolution version of these images because that's what the computer uses for determining which face is which face. So I'm going to click on this one. Okay, this is the face I just clicked on. This is the original face I clicked on, and it's going to compare these two faces. Well, it already did the comparison, but now we can actually do some investigation. Okay, so I can click here, and what this is showing me is the pixel value for this pixel right here, that's 120, and the pixel value for this one right here, that's 107. The computer uses these numbers to determine which color gray to show for each pixel. 120 is a little bit brighter than 107, although that's hard to see. But what it does, it takes the difference, it squares it, and it gets that value here. Let's grab another pixel. Okay, now these are a lot different. We've got, this is a very dark one, so it's a low number, 49. This is a much brighter one. It's a larger number, 160. Again, we get our square difference. Our overall square difference is a little bit bigger. This is the row and the column that these pixels are in for each image. Okay, now what we do here is it actually takes, for all 644 pixels, so 1, that's pixel 1, 1 through 644, we get the square difference for each one of those, we sum them up, and we get this value here. Then we take the square root, and that's how the algorithm determines which faces are closest to a given face. Now this is really nothing more than the distance between 2 point formulas. I'll take a look at that. Okay, now here's the distance between 2 points in 2 dimensions. Okay, so you have 2 coordinates, you get the distance between each coordinate, and you square it, and so forth. Okay, now 3 dimensions. Okay, so now if we pop out to 4 dimensions, now if we keep going to 644 dimensions, that's what the algorithm is using. Because we have 644 pixels, we consider each pixel to be a coordinate, but we use exactly the same formula. And that's what we're doing over here. We're getting the square differences between each pixel value and then summing it all up. So this is really the distance between 2 points formula, which is based on the Pythagorean theorem. Okay, we've got a scroll feature that allows us to scroll one by one through each pixel. We've got a tutor feature that will give a little tutorial as to what's going on. Now if we go back up to the beginning, we get to what I think is the cool part. Alright, so what's cool about this is, this really is not going to be the data that the students will use. The students will use their own faces. This is data that we got from the AT&T laboratories in Cambridge, which we're allowed to use as long as we reference. But what the students will do is put in their own pictures, and then they'll be comparing against their classmates. And that'll be kind of neat, because they'll be able to play with it. They could, for example, they could put makeup on to see if they can make themselves look like other students, or they could, make faces to see if they can make themselves look like other students, or if they can make faces that are wild enough to fool the application itself. So it would be a lot of fun. It's a modern application of the Pythagorean theorem that was actually used in a research paper. The idea here was based on a research paper from the 1990s. So it's a modern application of the Pythagorean theorem. And it's also a lot of fun. I think it's pretty cool.